sitting in a boatyard, it's sitting on whatever kind of keel it has. You know, all the weight is transferred directly to the ground, and then there's jack stands or poppets around it, balancing it and holding it up. The poppets don't actually do anything to hold the boat up, they just keep it from falling over, right? What we're doing in this case is taking out the foundation. It's like taking the foundation out in your house and leaving the house levitating completely around it without even really putting any cribbing or structure underneath the house. You know, if you've ever seen a house, foundation on a house replaced, they jack it all up, put big beams underneath it, and then put blocking underneath that to hold the beams up. Well, we're holding it up from the outside, effectively. So we spent at least a week building this elaborate structure consisting of molds which are formed to the hull and all this complex bracing and trying to transfer, trying to actually hang the boat in the air from the deck itself. And then bracing, we put a bunch of bracing inside the boat so that when we take the keel out and take out the blocking or the foundation underneath it, the boat itself will stay sitting in the air, not move around. And because we're taking out the structure that is essentially separating the roof from the floor, keeping that whole thing from collapsing at the same time. And I'm not an engineer. All I did was use common sense and, you know, what years of experience doing projects similar to this have taught me to do. And a good friend of mine, actually we were talking about him, John, this guy that I used to work for in Maryland, a guy named John Swain, always said, well, if you have any questions, build it 4 times stronger than you think you need to, and that'll never treat you wrong. So we built this incredibly complex structure underneath the boat and then proceeded to take her apart in the reverse process of how you would do it if you were building it. This picture is me actually holding a circular saw upside down, cleaning out the seams between the planks. The fuzzy stuff is cotton, all the cotton and the oakum that's in the planking seams. When you put a traditional boat together that's carvel planked or smooth planked, you actually put the planks to each other, leave a certain calculated amount of space, and then drive oakum, which is tar-soaked hemp rope, in there, and cotton, and that actually tensions the boards and keeps the water from passing through the seams. So in order to actually get the planks off, we have to take all of that out. The traditional method, I don't think there's a picture of it, involves like using a hook to just pull it out really, really slowly. And I have spent hours, probably days of time doing that on small and large boats. And the first thing I thought about doing on this job, when I realized that we had to reef all the seams, was trying to figure out how to do it in about, instead of spending 4 days, how to do it in 4 hours. The only difference between guys like me who practice the profession today and the guys 100 years ago doing it is that we have tools that allow us to do the job faster. Not necessarily better, but faster and easier and more time efficient, really.
How shallow or deep did you have the setting on that saw?
Just enough.
A quarter of an inch or so, just to grab it?
The planking is like 1.5 inches, and when you put carvel planks together, you actually fit them tightly to each other, but then you open up a portion, 1/3 to the half of that seam, and leave a really deep V, and then drive the fiber in there super hard, and as you drive it deeper into the V, it bunches up and tensions. So let's say that's 1/2 inch, maybe a little bit more. It was set just to that depth, so that it was actually, Christeen has had 2 strands of cotton in the deepest part and then 2 strands of oakum on top of that. It was just enough to pull the oakum out, but not really pull the cotton out. Like to kind of grab the cotton and loosen it up.
Oh.
So it was like 4 hours or something like that. It works.
Wow.
It works pretty well. It's very difficult to hold the saw upside down, and very easy to like make major mistakes, which we didn't do. This is actually a picture of us peeling the first plank off the boat. You can actually see that you can see the nails that we're holding the plank to the frames sticking out. In almost every case on a traditional boat of any size that has been put together especially with galvanized iron fastenings, the only way to get into the boat is with a saw, a chainsaw, a skill saw. Typically, you end up actually cutting your way in there to be able to get at whatever the problem is and destroying everything around it, planking, frames, whatever. Like if you had to get, I was sure when this job started that we were going to end up destroying all of the planking that was in our way, and we actually planned to take off 5 planks on the bottom from the keel up on each side, and then cutting a bunch of frames. We had planned on planking and cutting frames to get them out of the way so we could get the keel out. The reason that this job is so complex, and we'll see that in the next couple of pictures, is that the keel is fairly large, and the boat has sawn frames, which are fairly large also. Sawn frames are actually cut from curved timbers, and the frames on this boat are, I think, 3 by 6, maybe a little bit beefier, maybe 4 by 6 at the bottom, tapering to 3 by 6 at the top. But the real issue is that the frames are actually mortised into the keel. Because the boat has a centerboard trunk and because it was built on Long Island, and it seems to be that only boats on Long Island have this particular construction detail, but they all have it. All the old traditional ones, the frames actually go into the keel, and in order to drop the keel out, we actually had to take the frames out of the way. To take the frames out of the way, you have to take planking off. On a more modern built boat, you would basically, ideally, just be able to take the garboard planks off, one on each side, the ones closest to the keel, cut some fastenings, and the keel would just drop off because there wouldn't be that issue. The frames would be on top of the keel or fastened to floor timbers, which are on top of the keel. The remarkable thing about this whole thing, this whole project, is that at this point we haven't destroyed a single part of the boat. Even the keel came out as one complete piece. We had to make one cut to get it out. I was sure that we were destroying planks to get the boat apart, and we actually managed to come up with a system to start a wedge at one end and get a couple of pry bars under it, and we actually, you can't really see it clearly in these pictures, but all the plugs over the nails, we actually drilled all the plugs out, took a 3-pound sledgehammer and a 5-pound sledgehammer, a nail set and a sledge, and we pounded all the nails to loosen them up, and that actually, by driving them in, that broke the friction between the iron and the steel, or the chemical bond, which happens sometimes, and we were actually able to pull the planks off, which was crazy. Like this particular moment, there was one of the most amazing things that I've ever seen. I knew we were going to try to do it, but I didn't have any confidence in it. And we were discussing, the guy in the picture here is my friend Joe that's working with us, working for me. Joe and I were discussing for days, like, how long are we going to spend trying to pull one plank off? 2 hours, 4 hours, 8 hours before we just destroy the whole thing, before we just take the chainsaw out and start cutting our way in there. Because if it was going to take us too long to take them off, it's just much cheaper to just destroy the planks that are in your way and make them new again, as opposed to spending days and days trying to get them off. But we managed to pull off this remarkable system of just kind of peeling it out of the way, shocking the nails, and they all came off. That's a picture of the bottom, the keel, the frames with 5 planks off, and you can kind of see that the frames are mortised into the keel here. The way this was done is very typical on Long Island. The frame actually has a dovetail on one side, or a half dovetail on one side. Dovetail joint is what you see in your drawers and your furniture at home. It's just a method of locking 2 pieces of wood together without actually using any fastenings. So there's a dovetail cut on one side of the frame and on the other side of the mortise, on that same side of the mortise, and when the frame is put into the keel, you push it against that side and then drive a wedge on the back side, which keeps the dovetail locked in place. Very effective, very efficient, no fastenings, really strong, and a real bear to take apart. So what we did at this stage